Hi, good morning there, Science 10s. Today we're going to learn about ionic compounds. So we've learned about atoms and the periodic table, and we've learned about how atoms either lose or gain electrons to form these charged particles called ions. And so now we have to talk about what is an ionic compound and how do we name them. So there's always a competition for electrons, and the nonmetal is going to win the competition. It's going to gain the electrons from the metal, and the metal gives up the electron to create a positively charged ion, what we call a cation. And the non-metal, of course, gains that electron and it forms an anion, a negatively charged ion. So here we have the example of lithium. And this lithium atom, we know, is found in group 1. And all of our group 1 atoms have this one extra electron in that outermost, the valence energy level. And so here again is from our periodic table, our atomic number that tells us that we have 3 protons here in the nucleus, and we have to have, because it is an atom, there is going to be 3 electrons. And so we see 2 electrons in that closest energy level, and then here's this 1 electron that we're actually going to lose, we're going to get rid of. So the lithium loses the electron and it becomes a positive ion. Remember, all metals become cations. And then as a result of this, the non-metal is going to gain that. So in other words, I'm saying there is a transfer of electrons from the metal lithium to the non-metal. Now here we know that this is a fluorine atom. If you're not sure how we know that, well, count up the number of protons and the number of electrons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And so atomic number 9 protons, has to have 9 electrons to be an atom. This is our group 17, the very first atom in that group or family, and this is the fluorine atom. So once he gains this electron, now he's got this extra electron, and now he has a full octet. So now he has an extra. It doesn't have 9 electrons anymore. Now he just gained 1, and now he has 10 electrons, and that's why he becomes the fluoride ion. He's now a non-metal, and he is an anion. And you notice that when he's an ion, we don't call him fluorine anymore. He undergoes a name change. He is now the fluoride, and so the fluoride ion is transferring, it's receiving these electrons, it's gaining them from the metal. So this creates what we call an ionic bond. And an ionic bond is because of a transfer of electrons. So this is how ionic compounds form. We have a lithium ion, a positive cation, a metal, and then a fluoride anion. It's negative because it gained an electron. And notice the positive and the negative add up to 0. There's no charge. So the compound we would name LiF, and all ionic compounds are solid. So compounds are neutral. You have to have equal numbers of positives and negatives, and as a result, you have no charge on that particular compound. So ionic compounds, you can read through the properties of them, like solid at room temperature. That's why we write the state S in brackets as solid. They have high melting points. They dissolve in solution. They conduct electricity, and largely because they have a metal in them. So how do we name these ionic compounds? If I'm given a formula, how do I figure out what the name of that compound is? So here's an example, the formula NaCl solid. So the first thing we do is we have to name the cation. So we look up, and the first element, Na, we know that is going to be the cation. That is the metal. We always list the metal first in an ionic compound, and then the non-metal is listed second. So we look up, oh, well, here is sodium And sodium, again, is one of our group 1 metals. We know he has a positive charge. So Na positive, name is sodium. So that's going to be the first word in the name, sodium. Next, we have to name the anion. The second guy in the name is based on the anion. And so Cl, we see that is the second element. And we know when we look up that element, he's in group 17. And his name, Cl, that's not Ci, that's a Cl. His name is chlorine. Now remember, an atom is chlorine. When we are gaining electrons, now it is an ion. So we are renaming this nonmetal as chloride ion. So then all you do is you put those two words together. Here's your metal, sodium, and here is your ion, the chloride, the non-metal, the negative anion. You put them together, and the name is sodium chloride. So NaCl solid is sodium chloride. No capital letters, doesn't tell you how many of each ions. You just have to look up the names on the periodic table. Okay, so let's talk next about what do we mean by an ionic formula. When we look at our example here is CaCl2. So what does that actually mean, this CaCl2? Well, it means that there's two different elements in this formula. The metal, the one listed first, remember we always write the metal first, and it's saying that there's one of them. We don't write that because, you know what, honestly, we're lazy, scientists don't write it. It just means if there's no number there, you know there's just one of them. So our metal is calcium, and then our non-metal, the element, the atom, is chlorine. But remember that the name changes, and we are going to call him the chloride ion. So we have two different elements, calcium and chlorine, and we would name this guy as calcium. That's the name of the metal, and the chlorine becomes chloride. Okay, so we would name this calcium chloride. Why is it that I have to have two chlorines for every one calcium? Well, because calcium has a 2 positive charge. It is a group 2 ion metal, and each chloride, remember that the charges have to add up to 0. If I just had one chloride ion, I'd have a 2 positive and a 1 negative. That doesn't add to 0. So I need to multiply, and my multiplier, I'm timesing each of these. That multiplier becomes this subscript number, right? Now I have equal charges. Now I have 2 negative anions, chloride ions, and 2 positive and 2 negative adds up to a neutral 0 charge. All ionic compounds will have no charge, 0 charge. Okay, so here's an example. We've got lithium fluoride. That is the name of the ionic compound. Lithium is the metal. It has lost an electron, so we know it's the cation, Li+. So write down what the ions are, and then you are going to put them together. Now, you may have to do an energy level diagram. If you don't remember how to do that, go back to your notes. So there we've got lithium. He's Li positive. Now, oxide, what are we talking about? We're talking about oxygen. And oxygen is in group 16. And we know that everybody in group 16 must gain 2 electrons to become an ion, to fill out their octet so that they have a full outer energy valence level. So lithium is Li plus 1, oxide ion is O2 minus. So how did I know that? Again, I looked up on my periodic table, right? And I understand that as an atom, I have 8 is my atomic number. That is my number of protons. That is also my number of electrons. So here is the atom that has 6 and 2 is 8 electrons to match up my 8 protons. But I'm gaining electrons and I'm forming the O2 minus ion. Now I have 8 electrons. I have a full outer valence, and that number of electrons now means I have 2 more negatives. That's why I have the oxide ion. Okay, so again, I now have a charged ion. I have lithium positive, oxygen, oxide ion, 2 negative. Those charges do not add up. That is not balanced. So what do I have to do? Well, I have to use a multiplier. Lithium, I have to multiply by 2. And now I have 2 positives, and that matches up with my 2 negatives. Now the charges are balanced. I have 2 positives, that matches with the 2 negatives. So this multiplier that I use becomes the subscript in the formula. Li2, oxygen, I just multiplied by 1. And so his multiplier is 1. Li2O1 becomes the formula for this ionic compound, lithium oxide. So again, we typically don't write a 1, we just write Li2O solid. Okay, so that's how we write our formula for lithium oxide. Now, you're going to try one on your own, and then you're going to work through your booklet that you have on ionic compounds, and you're going to do the univalence. All of these metals have only one possible charge. So magnesium, a group 2 metal, is Mg2+. You look him up on your periodic table. He's in group 2. He has a 2+ charge. Phosphorus, well, phosphide is the name of the ion, and he is in group 15. And so we know that just like nitrogen, he is going to form an anion, 3 negative charge. So if you look at the charges, they do not add up to 0. 2 positive does not equal 3 negative. So you have to find the lowest number that both 2 and 3 go into. So I just multiply the 2 numbers together. That's your lowest common multiple. All right, so magnesium, 2+, I times him by 3. This 3, the multiplier, goes into the formula here. Phosphorus, I multiply by 2. Now I have 6 negatives to add up to the 6 positives. I now have a neutral compound. This goes in my formula here, Mg3P2. How much are my charges? I have 6 positives, I have 6 negatives. Charges add up. I now have a neutral compound. This is an ionic compound because I have a metal and a non-metal. Okay, so hopefully you guys can now be able to do some practice of your univalence, all of these metals that have one charge. And so group 2 metals like magnesium and calcium and beryllium, also group 1 metals like lithium, sodium, and you will also see group 13, aluminum, gallium. Those guys are univalent, and those are the metals that form an ion charge. That is a cation because they're losing electrons. Okay, so you guys go ahead and work through your ionic compounds naming booklet. Get a practice making the name when given the compound formula, and vice versa, right? If you're given the formula, you should be able to make the name of the ionic compound. As always, if you have any questions, let me know, michelle.ladine@ghsd75.ca. Take care. Talk to you later.